Okay, let's do some problems out of section 2.3. The first one that we're going to do is number 29. And in number 29 it says find the derivative of the algebraic function. Our first function is 3x minus 1 over the square root of x. So let's find the derivative. To find the derivative, gotta bring up my pen here, we use the quotient rule. And with the quotient rule, we take the down. It's down d up minus up d down divided by down squared. So that's down square root of x. We'll use x to a 1/2. D up, right? So the derivative of whatever our up function is. So the derivative of our up function is 3, right? So that's the derivative of 3x, which is 3, plus the derivative of negative 1, which is 0. So that's 3. Minus up, which is 3x minus 1. D down, and let's use a little scratch variable here. We'll call it u, equals square root of x, which is x to a 1/2. And here we can use the power rule, right? So u prime equals, bring the 1/2 down, x to a 1/2 minus 1, which is negative 1/2. So that is 1/2 x to a negative 1/2. That's that whole quantity there. And we want to make sure that we emphasize that that is indeed negative 1/2. Okay. And then that's all going to be divided by down squared, and down is square root of x, so square root of x squared is just x. Alright, so we notice that we have some, let's see if I can make the color different, some nasty rational exponents. Not nasty, just maybe inconvenient. So let's try to get rid of these rational exponents by taking out one of the, factoring out an x to a, let's say, negative 1/2 from these two terms, and seeing what our new equation ends up looking like. So I'm going to take out an x to a negative 1/2. Okay. So in the first term, we don't know quite what to take out yet. In the second term, we're going to take that x to a negative 1/2 completely out. It's just going to factor. So what's going to be left over here is going to be minus 3x minus 1 times 1/2, right? Because if we were to redistribute this into that term, we would just put the x to the negative 1/2 back again. So what happens over here? Well, we have a 3, we have an x to the 1/2, and any time that you take a factor out, or you factor out something from a term, it's just like dividing by that thing that you factored out. So let's say to this term, we can multiply by 1 over x to a negative 1/2. Why does that work like it does? Well, if I were to redistribute to this term that now has 1 over x to a negative 1/2, if I were to redistribute this to this term, the x to a negative 1/2 would cancel out with an x to a negative 1/2, and I would end up exactly right back where I started, which is something that I want, because it has to end up equaling whatever I started out with. So let's divide that by that x right there and figure out what this becomes. So this is going to be, right, I'll carry down that x to a negative 1/2, right, and then we have 3. Okay, so here I have x to a positive 1/2 times 1 over x to a negative 1/2. So I have a common base that is being divided, so I can use the properties of exponents and say that this is going to be x to a 1/2, right, and I'm going to take the positive exponent of 1/2 and minus the exponent that appears in the denominator. So that's going to be 1/2 minus negative 1/2, which is just going to be x to a first. So that just becomes x. And then I still have here minus 1/2 3x minus 1 divided by x. Similarly, in a similar fashion to what we did with the rational exponent, because it was kind of hard to work with, and now we have all integer exponents, we can try to factor out this one term of 1/2, right? So we take it out, which gives us, really what that does is brings out a 1/2 times x to a negative 1/2 all over x. And then when we when we factor out, right, we said that we just divide by the thing that we factored out. So 3x times 1 over 1/2 just becomes multiplication by 2. So this will become 6x. Another way to see that is, if I were to distribute to this term, what would this have to be in order to get back to where I was? So if I take out a 1/2, clearly I would have to, or if I were to redistribute this 1/2 to 6x, I would get back to 3x. And then we took out a 1/2 here, so that's just going to be minus 3x minus 1. Okay, so we can simplify this. We have a 1/2 up here, and that's the same thing as multiplying by 1/2 on the outside. So what we can really just do is bring this 2 down here, right? So this is the same thing as multiplication by 1/2 times 1/2. And we can just have this denominator be shared by all the factors right there. So another way to write that is just to write it with a 2 on the bottom there in the denominator. Okay, so then we have a negative exponent right here, and this is all one factor by itself. So we can even take this and bring it, maybe I'll just take the whole thing down there. I'll just recenter that 2x that we had there from before, and that is x to a 1/2. So let's simplify this out. This negative distributes to the two terms that are located right here. So that's going to be 6x minus 3x plus 1. I don't even really need this grouping symbol anymore that's on the outside here, because I'm not multiplying by anything. And that's going to be divided by 2x. Now I'll bring back that root notation because it's just so cool. And then this is going to become 3x plus 1 over 2x square root of x. Okay, and I believe that that will be the correct answer. The only thing that they did instead, right, was if we look in the back of the book, they have, where is it? 3x plus 1, right, which is what we have on the top there, so that's good, times 2x to a 3 over 2. And that's simply just, I shouldn't have converted back, I guess, over to this root. I guess they wanted all this in the same base. So this is the same thing as having to a first power right here. So when I combine these two exponents together by adding their exponents, that's 1 plus x to a 1/2. So this is the same thing as 3x plus 1 over 2x to a 3 over 2. I just combine these two exponents right here. And that would be number 29. So I don't want to put too much on one video, so that will be this video, and the next one that we'll cover is number 13. So I hit